We shall now switch over to learn another application of integration. Actually, from the very definition of a Riemann integral, the basic definition has been created about integral a to b f of x dx with the help of area concept itself. What I mean to say is, suppose this is the graph of a function, say y is equal to f of x, defined on the closed interval a to b, defined on the closed interval a to b. So, the graph itself looks continuous and bounded also between a and b. The supremum of f of x is this and the infimum of f of x is this. What I mean to say is the maximum value and minimum value of f of x surely exist. Suppose we have split this into so many slices like this. If this width is some delta, you complete the rectangle here like this, like this, like this, like this, like this. As this is a rectangle, it very convenient to say the area of this rectangle. Just like that, you will be able to have this area also, like this area also. And if you add all the areas of these rectangles which have been formed below the curve, all these rectangles have been formed below the curve above x-axis, isn't it? The sum of all the areas of these rectangles is called the lower area of f of x above x-axis. Similarly, see, there has been another rectangle here also. This is, let us for the present call them upper rectangles. It is sure that area of the upper rectangle is less than that of lower rectangle, and at some cases they might become equal. Therefore, so the sum of all the rectangles which have been considered as upper rectangles is then termed as upper area. And if you increase the number of slices here like this, then the difference between the areas of upper rectangles and lower rectangles will be diminished. So, if n is the number of parts, then limit as n tends to infinity, areas of these rectangles gives the area under the curve. With that concept, it has been defined that it is nothing but the integral a to b f of x dx. Of course, the mathematician called Riemann could introduce this concept. That was why previously it was called a Riemann integration. And we are enjoying the fruits of that Riemann integration. And this, after getting defined, we are making use of to find the areas. This is the basic concept, of course. A definite integral can also be expressed as a limit of a sum. What is the sum? Sum of all the areas of these rectangles, isn't it? That is why this is the basic concept behind finding the area of f of x below the curve, above x-axis, and between the limits x equal to a and x is equal to b. What is this one? This line, rather this ordinate x is equal to a and this is x is equal to b, isn't it? between A and B. Well, and by taking this concept in view, we'll have the fresh definition to evaluate any area. Suppose there is a curve like this. This is A, this is C, this is B. Area bounded between x is equal to A, x is equal to B, y is equal to f of x and x-axis. Suppose he asks you, some part of the graph lies below x-axis, therefore this area is to be found and again this area is to be found. To have this integral a to c f of x dx is to be calculated, and to have this integral c to b f of x dx is calculated. See, the main item here is f of x is negative in this one, f of x is positive in that region. What makes sense, or what are all the differences that it can create in calculating the area? That is a special discussion. To avoid such confusion, to avoid such discussion, we take part in defining the area or calculating the area like this. Integral a to b mod f of x dx is the area bounded by y is equal to f of x, x-axis, between x is equal to a and x is equal to b. Between x is equal to a and x is equal to b. So, if f of x lies in the positive region, that is in the above x-axis, we just take f of x, and if it lies in the fourth quadrant or in the third quadrant, that is below x-axis, then it is supposed, it is supposed to estimate that f of x is negative below x-axis, and in such a case we take minus f of x in that region. Why? Because area concept, it is a positive numeral. Nobody agrees to say that area is negative. So, while using definite integral concept, integral a to b mod f of x dx is to be formed. That is why this gives you the formula or definition or concept, whatever you say, the area of the region bounded by y is equal to f of x and x-axis between the limits x equal to a and x is equal to b. X is equal to a and x is equal to b. Okay. Next one. There are certain concepts which are to be kept in mind while finding the area. Out of them, the first concept is symmetry. For example, find the area bounded by y square is equal to 4x and x is equal to 1. That's all he says. You must be able to know the nature of the graph of the function which has been given in the question. Unless or otherwise, it might be a tedious job to have the limits of integration. You recall y square is equal to 4x is a parabola, isn't it? One more thing to say is, it is the parabola y square is equal to 4x. Here, even powers of y are being observed. Hence, it is symmetric about x-axis. X is equal to 1 means this is the line parallel to axis. This is the point. X is 1 means y is 2. X is 1 means y is minus 2. The thing to be observed here is this area and this area are one and the same because the curve is symmetric about x-axis. Why should it be? Because it holds even powers of y. Even powers of y. In a similar way, if there is a curve which contains even powers of x, say x square is equal to 4y, then it is symmetric about y-axis. Suppose a line is given like this. This area is equal to this area. What I mean to say is, you must be able to observe the symmetry of the curve, if any, if at all there is any. In these examples which we have discussed, the first curve is symmetric about x-axis and this is symmetric about y-axis. And by thinking of that symmetry, it is not necessary to find these two areas. You just find this area. This area is, if this part is 0 and this part is 1, integral 0 to 1 y square is equal to 4x, means y is equal to root 4x, that is plus or minus 2 root x or 2 root x dx. Why should you take 2 root x only, not minus 2 root x? If you want to find this area, you take minus 2 root x, because the curve lies below x-axis here and it is supposed to be negative. That is why y is minus 2 root x, but here it is 2 root x only. You find the area and 2 into. Why do you put 2 into? This is one part, this is one part. This definite integral gives you this area only, but not this area. Therefore, this area, if you take some k, this is also k, so total is 2k. So 2 into area of that. So by observing the symmetry, we find the areas somehow easily. Why? Because we reduce the strain, of course. Let us see some standard examples. Find the area bounded by. Find the area bounded by y is equal to mod x and x is equal to 2. That's all he is giving. That's all he is giving. And x-axis. We must be able to draw the graph of y is equal to mod x. I think you know, if x is positive, the line is y is equal to x. If x is negative, y is equal to minus x. Like this, the graph goes. This is y is equal to mod x. X is equal to 2 only. X is equal to 2 only. This is, of course, the line x is equal to 2. X-axis, y is equal to mod x and x is equal to 2. This area only is required. It is very simple, isn't it? If x is equal to 2, automatically y is also 2. This point is 2 comma 2. This area is integral 0 to 2, y is equal to mod x. Do you take plus x or minus x? This is in the positive region, x dx. So it is x square by 2 between the limit 0 and 2. And if you take 2 in the substitution, 2 square by 2 is 4 by 2 is 2, and if you take it is 0. See, actually speaking, here you need not use integral concept. Base is 2, height is also 2. Half into base into height, half into 2 into 2 gives you 2 units. Gives you 2 units. Yes, therefore the answer is 2. Now let me change the question. Suppose x is equal to minus 2 and x is equal to 2. He asks you. Then what happens? Minus 2 lies here. So that area plus this area. That is 2 units. This point is minus 2. This length is 2 units. This length is 2 units, isn't it? Again, half into base into height, half into 2 into 2 is again 2 plus 2, 4 units. 4 units. Well, my dear, while estimating this one, we could have not made use of integration concept. Of course, for this we have used it. We could get the same answer as if we proceed to find the area using half into base into height. Well, in order to make use of integral concept to find this integral, what do you do? Integral minus 2 to 0 minus x dx. Why should you take like that? Why should you take like that? In this part, this is mod x. Y is equal to mod x. But x is negative here, isn't it? X is negative. Mod minus x is x. So that even if you take, you will be getting the same answer as that. Okay, one more thing. Find the area bounded by the ellipse x square by a square plus y square by b square is equal to 1. Well, my dear, observe the nature of the function. It contains both even parts of x and even parts of y also. By the nature of the curve, that is ellipse itself, we see that it is symmetric about both x-axis and y-axis. Well, my dear, let us recall the shape of that ellipse. We all know from the fundamentals of conic sections, this is x-axis, this is y-axis, this is a0, this is minus a0, this is 0 minus b, this is 0b. What do you notice or what do you use from the knowledge of symmetry? Equation of the curve of f of x, that is, contains both even parts of x and even parts of y also. So it is symmetric about both x-axis and y-axis. First of all, contains even powers of y, symmetric about x-axis, symmetric about x-axis. Therefore, if this area is k, this is also k. Okay, it contains even parts of x also. It is symmetric about y-axis. So if this is k, this is also k. If this is k, this is also k. K. How many k's? 4 k's. As a result, the entire area which has been required has been divided into 4 equal parts. How many equal parts? 4 equal parts it has been made. Therefore, to have that area, it is just enough to find this area and you multiply that with 4. You find this area and multiply it with 4. That is, required area is equal to 4 times integral 0 to, we are moving on x-axis. On x-axis, x varies from 0 to a of y dx, isn't it? Actually speaking, mod y dx we must take because we are considering the area in the first quadrant itself. In the first quadrant, mod y is y, isn't it? So, well, from this, first of all, you must get a formula to find y. What is y? Y square by b square is equal to 1 minus x square by a square. That is a square minus x square by a square. Y square is equal to b square by a square into a square minus x square, or y is equal to plus or minus b by a into root of a square minus x square. And as we need or as we take interest in finding the area involved in the first quadrant itself, we have to take y is equal to plus b by a into y, because y is f of x. In the very definition, in the beginning itself, we have taken the area as integral a to b mod f of x dx. Modulus of that is b by a into is equal to 4 into integral 0 to a b by a into root of a square minus x square dx. So this is 4b by a into what is the integral of root a square minus x square? It is one of the standard formulas. It is x by 2 into root of a square minus x square plus a square by 2 into sine inverse x by a between the limit 0 to a. Between the limit 0 to a. Hence, if you take in the substitution, if you put a in the place of x square minus a square is 0, the first part is 0, a by a is 1, sine inverse 1 is pi by 2, so it is a square pi by 4, a square pi by 4 minus, if you take 0, 0 minus 0, that is 0 plus 0 is again 0, hence it is, if you can cancel a and 4 and 4, it will be pi ab. Like this we find the area of an ellipse. Area of an ellipse, like that. Well my dear, you need not do this step also. It was a famous formula, integral 0 to a root of a square minus x square dx is nothing but a square pi by 4. You please recollect that from definite integrals. That is integral a to 0 to a root of a square minus x square dx is a square pi by 4. So that it is 4b by a into a square pi by 4 gives you pi ab. Okay. Can we derive the area of a circle of radius a from this? And from our earlier mensuration of our earlier classes, we pretty well know that the area of a circle of radius a units is pi a square. My question is, can you derive that concept from this area? Why not? See, from the knowledge of conic sections, an ellipse is just nothing but a stretched circle, isn't it? If you stretch it, major axis and minor axis will be observed. If you again put them close, that is when a is equal to b, it becomes a circle. This length is a, this length is b. If you reduce a or adjust a and b so that they become equal, then this shape will be contracted like this to form a circle. What I mean to say is an ellipse in which a is equal to b becomes a circle of radius a. Well done. To estimate the area of a circle in pi ab, you put b is equal to a. Pi a into a is nothing but pi a square. Hence the area is pi a square of a circle. Good. This is the area of a circle. SS, of course. The way of deriving area of a circle from the area of an ellipse. Well, my dear, I like to ask you one more question. In this ellipse, the major axis lies along x-axis. If there has been given another ellipse whose major axis lies on y-axis, do you have any change in the area? Do you have any change in the area? No change at all. Then also the answer is pi ab. The numbers will just be reversed, interchanged rather. So that the answer is pi ab. Like this you can observe that ellipse. The area bounded by mod x plus mod y is equal to 1 that is the question he is asking. See, mod x means x if x is positive minus x if x is negative. So by observing all the possible cases of x and y, this equation can be written as x plus y is equal to 1 if both x and y are positive. X minus y is equal to 1 if x is positive and y is negative. Minus x plus y is equal to 1 if x is negative and y is positive. Minus x minus y is equal to 1 if both x and y are negative. So, by looking at all these four cases, we can easily understand that all these four correspond to four straight lines. Four straight lines. What are those four straight lines? This is 1, 0. This is 0, 1. This is minus 1, 0. This is 0, minus 1. Observe this. X plus y is equal to 1. What do you say about this? X plus y. This is minus 1, 0. This is 0, minus 1. X-intercept is 1, y-intercept is 1. X plus y is equal to 1. X-intercept is minus 1, y-intercept is 1. This is the line. What do you say about this line? X-intercept is minus 1, y-intercept is also minus 1. This is this line. What do you say about this line? X-intercept is 1, but y-intercept is minus 1, hence it is x minus y is equal to 1. And it is a very easy matter. Even if you do not use integration concept at all, you can be in a position to trace the answer very simply. Why? Because it is a square, you see, in which each side is root 2. Hence its area is 2. Or otherwise, this is a right angle triangle, you know. Base is 1, height is 1. Hence the answer is half into base into height, that is half. Half. With the similar concept, this is half, this is half, this is half. 4 halves, 2. So area is equal to 2 square units. 2 square units. Well, my dear, in order to, if you want to use integration concept, you need that actually, these are all symmetric, you know. You just have integral 0 to 1 of x plus y is 1. So y is 1 minus x. The equation of this line is x plus y is equal to 1. And y is 1 minus x. Integral 0 to 1, 1 minus x dx. You just find it will be half. 4 into half is 2. Area is 2 square units. It is one of the most standard questions with having the standard answer. You need not put any step. You just remember that the area bounded by that curve or the set of straight lines given by that equation is just nothing but 2 units. That is 4 into half units, like that. Well, another standard question we'll be going to look at. Another standard question. Find the area bounded by y is equal to x cube and x axis between x is equal to minus 1 and x is equal to 1. Yes. Well, my dear, without looking at the graph of the given function, if you just find integral minus 1 to 1 x cube dx, x cube is an odd function, it is 0. Is it the area 0? No. That is a dangerous way of thinking. Do not think of that like that. Why? Because between minus 1 and 1, you are supposed to have mod x cube but not x cube. Why? Because in the very beginning, the very fundamental formula, integral a to b f of x is not given. Integral a to b mod f of x is given. So, you must be knowing when can this be positive and when can this be negative. So, it is a must to look at the graph of the function. Observe that. So, from minus 1 to 1. Minus 1 to 0, it lies below x-axis, and 0 to 1, it lies above x-axis. Isn't it? It lies above x-axis. Therefore, the answer is, how can you split it? How can you split it? From minus 1 to 0, it acts in one way, and from 0 to 1, it acts in another way. Therefore, the actual solution, rather the actual area is required area. Integral minus 1 to 0 mod x cube dx plus 0 to 1 mod x cube dx. Between minus 1 and 0, what do you say about x? It is negative. X cube is also negative. Then mod x cube is minus x cube. Hence it is integral minus 1 to 0 minus x cube dx plus from 0 and 1. What do you say about x? It is positive. X is positive. Therefore, x cube is also positive. Hence, mod x is just nothing but x cube dx. What is this integral? Minus x power 4 by 4 between the limits minus 1 and 0. And here it is x to the power of 4 by 4 between the limits 0 and 1. Minus of. If you put 0, it will be 0. If you put minus 1, then it is 1 by 4 plus 1 by 4 minus 0. Altogether, minus of minus 1 by 4 is 1 by 4. 1 by 4 plus 1 by 4 is half. The required area is half. The required area is half. Like that, we will be able to estimate. Well done. Another standard question which we will be looking at. Find the area bounded between y square is equal to 4x and x is equal to 1, which we have discussed previously. Let us estimate its answer and the way of finding it. First of all, what is the curve actually given? Y square is equal to 4x is a parabola having symmetry about x-axis. Why do you believe it? Because it is possessing even parts of y, symmetric about x-axis, and x is equal to 1 is this line. So this point is 1, 0. And we believe that this area is just equal to this area also. Hence, the required area is 2 into integral 0 to 1. Why should you put integral 0 to 1 only? On x-axis, x ranges from 0 to 1 only. And in this region, what is the curve? Actually, y square is equal to 4x means y is equal to plus or minus 2 root x. But we like to find this part. Hence, it is 2 root x only. So, 2 into 2 root x dx. 2 2s are 4. What is the integral of root x? 2 by 3 into x root x between the limits 0 to 1. If you put 1 in the place of x, it will be 1. Otherwise, it is 0. All together, it is 8 by 3, so many square units. Because it is area. Because it is area, it is supposed to be expressed in square units. This is in this way we find it. Another question. Find the area bounded between y square is equal to 4x and y is equal to x. He has not given any boundaries or any limits or any other thing. You may have to understand by looking at the nature of the graphs of the functions, two functions given there. What are the functions actually? Y square is equal to 4x and y is equal to x. Imagine that y square is equal to 4x is like this. And y is equal to x. We all know that it is the bisector of the angle between x-axis and y-axis in first quadrant, having slope 1. Hence, the line like this lies like this. What is the required area actually? The area bounded between these two graphs. This is the area required. Well, first of all, we must be knowing the points of intersection of these two curves. Where do these two meet? Automatically at origin they do meet 0, 0. And what will be this point? Look here, y is equal to x and y square is equal to 4x. If you take y is equal to x here, x square is equal to 4x, isn't it? X square is equal to 4x. That is x square minus 4x is equal to 0. That is x into x minus 4 is equal to 0. So x is equal to 0 or x is equal to 4. So what are the points of intersection of these two curves? 0, 0 and effect 4, 4. Therefore, this is 4, 0. And this point is 4, 4. Okay. Let us find the area. If you use this curve, y square is equal to 4x, if you use the integral concept, entire area below that is obtained. If you take y is equal to x, area below this is given. So, this area minus this area gives this area, isn't it? Therefore, required area is equal to integral 0 to 4, which curve lies at the upper place? Y square is equal to 4x or y is equal to x? You please look at y square is equal to 4x lies here in the upper place. The y is equal to 2 root x plus or minus 2 root x or 2 root x. We are in the first quadrant, hence it is 2 root x dx minus integral 0 to 4 x dx. Hence the answer is 2 into, what is the integral of root x? 2 by 3 x root x between the limits 0 to 4 minus, what is integral of x? X square by 2 between the limits 0 to 4. 2 into 2 by 3, 4 by 3 into, if you take x is equal to 4, 4 into root 4, root 4 is 2. 4 into 2 is 8. And if you put 0, it will be 0. Minus, here, 4 square, 16. 16 by 2 is 8, of course. Hence, this is equal to 8 into 4 by 3 minus 1. It is 8? It is 8. 4 by 3 minus 1 is 1 by 3. Hence, the answer is 8 by 3. Hence, the answer is 8 by 3. So many square units. By observing this problem, we can create a formula type statement. What is that? Let us try. Area of the graph bounded by y is equal to f of x and y is equal to g of x between the limits x is equal to a and x is equal to b, then the required area can be obtained as integral a to b mod f of x minus g of x dx. Why? Because who knows which curve lies at the upper place? If y is equal to f of x lies at the upper position, integral of f of x minus integral of g of x becomes the answer. If g of x lies at the upper position, then integral g of x minus f of x becomes the answer. Whatever might be the case, there is no sin at all by taking mod f of x minus g of x as the required integral to have the area. So this is the formula or format that must be used to find the area involved between two curves. Right. So far we have observed the areas above x-axis. In a particular case, you observe this figure. This is a parabola, of course, having vertex at 1, 0. Find the area between y-axis and this curve. In what way should we have? So, you must be able to write x is equal to f of y. X is equal to, and in that case, the required area will be integral c to d x dy. X dy. F of y dy rather. F of y dy, because the area has been considered based on the y-axis. Then also, if there is an area bounded between two functions x is equal to f of y and x is equal to g of y between the same limits a and b, then integral a to b mod f of y minus g of y dy. As in the previous case, we obtain the answer. So depending on the nature, shape, position of the curve, and according to the convenience, we find the area either based on x-axis or based on y-axis. Of course, while finding these areas, the concept of symmetry must also be kept in our mind. The concept of symmetry must also be kept in our mind. Yes. Well, among the standard functions, some more functions are there. Find the area of sine curve. Y is equal to sine x between 0 and pi. Between 0 and pi. We know that the nature of the sine curve between 0 and pi, absolutely it lies above x-axis, isn't it? It lies above x-axis, so strictly non-negative. Hence, required area is equal to integral 0 to pi. It is positive. Mod sin x is actually speaking in the format we must take mod f of x, that is mod y, that is mod sin x. Mod sin x is nothing but sin x. So, sin x dx. What is integral of sin x? Minus cos x between the limit 0 to pi, minus cos pi minus cos 0. Cos pi is minus 1. Minus 1 minus cos pi is minus 1. Cos 0 is 1. Minus 1 minus 1 minus 2. Hence the answer is 2. Therefore, this area is 2. Well, my dear, let me change the question. Instead of 0 and pi, if I ask you 0 and 2 pi, what happens to that? What happens to that? So another part will also be added here. From pi to 2 pi also another part will be added here. What will be the shape of that curve then? What happens? 0 to pi mod sin x dx plus pi to 2 pi mod sin x dx is equal to integral 0 to pi. What is mod sin x? Between the limit 0 and pi, mod sin x is sin x, plus pi to 2 pi. What is mod sin x? From pi to 2 pi, the curve lies below x-axis, it is negative. Hence, mod sin x is minus sin x dx. So, what is integral of sin x? Minus cos x between the limit 0 to pi, the previous answer of course, plus what is integral of minus sin x? Cos x. Cos x between the limits pi to 2 pi. Pi to 2 pi. What is this? We have just previously calculated it. It has been represented in the figure also. 2 plus what is cos 2 pi? 1. What is cos pi? Minus 1. 1 minus of minus 1 is 2. This part is 2 and this is also 2. From this, a beautiful concept can be kept in mind. Between 0 and pi, area is 2. Between pi and 2 pi, 2. Between 2 pi and 3 pi, 2. 3 pi and 4 pi, 2. Between any two successive multiples of pi, area of y is equal to sin x is 2 square units. Well done. Now I will ask you area between pi and 7 pi of sin x dx. What is the answer? Between pi and 7 pi. Pi to 2 pi, 2 pi to 3 pi, 3 pi to 4 pi, 4 pi to 5 pi, 5 pi to 6 pi, 6 pi to 7 pi. How many intervals? 6 intervals. For each interval, the answer is 2, hence the answer is 12. I think you could have got the point. For one semi-loop, 2. How many semi-loops are there? From pi to 7 pi he is asking. So 6 parts are there. 6 into 2, 12. Answer is 12. Similarly, I like to ask you between minus 4 pi to 8 pi. What is the area of the curve y is equal to sin x? Minus 4 pi to minus 3 pi. Minus 3 pi to minus 2 pi. Minus 2 pi to minus pi. Minus pi to 0 like that. How many parts? 12 parts are there. So the answer is 12 choose 24. How many? 24. 24 will be the answer. Okay, well my dear, does this happen for the case of y is equal to sin x only? Or y is equal to cos x also it stands true? Let us now discuss with that. What happens for y is equal to cos x? Y is equal to cos x. For y is equal to cos x, 0 to pi by 2, pi by 2 to pi. 0 to pi by 2, pi by 2 to pi. This is the area. That is the area. Integral 0 to pi cos x dx. If you put just this step only, answer becomes 0. Why? Because what is cos of pi minus x is minus cos x, isn't it? So f of 2a minus x is equal to minus f of x, then the area is 0. So you don't calculate the area like this directly, it becomes 0. Even in the previous case, to calculate the area between 0 to 2 pi of sin x, what happens to this? Sin of 2 pi minus x is minus sin x, even that is also 0. So don't get it integrated directly. You must be knowing the nature of the loop, the main graph of the function. Well, what is say about this? Integral 0 to pi cos x is integral 0 to pi by 2 of cos x plus pi by 2 to pi of cos x. My dear friend, in the case of sin x, between 0 to pi means one loop completely formed. Here, half loop. Half loop plus half loop. Let us try. What do you see? What is integral 0 to pi by 2 cos x? What is the integral of cos x? Sin x between the limit 0 to pi by 2 plus sin x between the limits pi by 2 to pi. Sin pi by 2 minus sin 0, 1 minus 0. Sin pi minus sin pi by 2. What is it? 0 to pi by 2 of cos x is sin x, and the sin that we have done here, it is minus cos x. You have to take why? Because there it lies in the denominator. I mean in the fourth quadrant. So minus cos x you have to take, hence it is minus sin x, hence this is minus, hence it is 2. It is 2. Here we have taken the limits from 0 to pi. Even then this area 2 square units is similar to that of a loop in the sine curve. But we shall now gather a loop of y is equal to cos x. When can you observe a perfect loop here? Minus pi by 2 and pi by 2. Pi by 2 and 3 pi by 2, like that, then only. Well, what is the area between minus pi by 2 to pi by 2 cos x dx? Here we are lucky to have the graph entirely above x-axis. Between minus pi by 2 and pi by 2, it is above x-axis. Hence the answer is, what is integral of cos x? Sin x. Between the limits minus pi by 2 to pi by 2. Sin x, sin pi by 2 is 1, sin minus pi by 2 is minus 1, 1 minus of minus 1 is 2 square units. So, we see area of a loop in the sine curve, area of a loop in the cosine curve remains same as 2. In the case of y is equal to sin x, between any two successive multiples of pi, 0 to pi, pi to 2 pi, 2 pi to 3 pi, 3 pi to 4 pi, like that, 2, 2, 2, 2, like that will be added. And here any two successive odd multiples of pi by 2, minus pi by 2 to plus pi by 2, pi by 2 to 3 pi by 2, 3 pi by 2, 5 pi by 2, 5 pi by 2 to 7 pi by 2, like that, 2, 2, 2, 2, 2, like that. Come on. Now, what is the area of y is equal to cos x between 3 pi by 2 and 11 pi by 2? How many loops will be there? 3 pi by 2 to 5 pi by 2, 5 pi by 2 to 7 pi by 2, 7 pi by 2 to 9 pi by 2, 9 pi by 2 to 11 pi by 2. How many parts? 4 parts. So, the required area is 8 square units. How much? 8 square units. For the case of a sine function, between any two successive multiples of pi, the area is 2. Between any two successive odd multiples of pi by 2, don't say that any two multiples of pi by 2, but any two odd multiples of pi by 2, the graph of y is equal to cos x bears the area 2 units. So keep it in mind, so that we will be able to have the area on this part itself. We can read it like that. Yes. And we shall look at some more standard results in the due course of time.